Hey everybody, this is Alex Merced, and welcome to the first session of our Lakehouse Catalog Crash Course. Now, the purpose of this course is to kind of understand the sort of burgeoning world of Lakehouse catalogs, why they matter, why they're important, and then the next two sessions will be about sort of like the different actual catalog implementations and their nuances of how they work and the features that they have. So again, today's session, we're talking about what are data lakehouse catalogs, kind of really laying down the history of the term catalog and what do they mean, how do they function, what role do they play. Then on November 26th, we're going to be going over specifically the Nessie and Polaris Iceberg catalogs. And on December 10th, we'll discuss other catalogs such as Unity, Gravitino, and Hive, AWS Glue, and others. So overall, by the end of this course, the idea is that you'll be very comfortable understanding the world of Lakehouse catalogs and what's the difference between sort of a Lakehouse catalogs and other things that are called catalogs. So again, my name is Alex Merced. I'm also one of the co-authors of Apache Iceberg, the Definitive Guide, and you can get yourself a copy of Apache Iceberg, the Definitive Guide by scanning this QR code. So if you don't have a copy already, do scan the QR code and pick up a copy. And also, I'm the host of Gnarly Data Waves, our very frequent podcast here at Dremio, and you can make sure you never miss an episode by subscribing to Gnarly Data Waves on Spotify or iTunes, and also subscribing to the Dremio YouTube channel at youtube.com/Dremio. Basically, we have all sorts of guests all the time talking about the data lakehouse space, about the data lakehouse implementations, about different data lakehouse technologies. Definitely worthwhile, especially we have a really cool backlog of previous episodes. So now let's begin with our featured presentation. Let's talk about sort of what is a catalog. And to really kind of appreciate catalogs, let's just kind of go back with sort of like the history of sort of like data systems and what are the kind of data systems that people work with. Okay, I mean, traditionally we work with like databases and data warehouses. And the beauty of these systems is that they do several things for us. They abstract away a lot of things. One, they abstract away how the data is stored. So when I do a create table statement in Postgres, that data is stored somewhere, it's tracked somewhere, but again, I don't need to know those implementation details. It just kind of works. It's a table format. Now that data that's stored, how does it know which data belongs to table A versus table B versus table C? Again, these are implementation details that are abstracted away from me, which makes my life a lot easier because I don't have to think about it. I just know that I can use this database or this data warehouse and it just works. Then there's a catalog, okay? And the catalog here acts as like a listing of those tables. How does it know that there is table A, table B, table C, table D? Because there's a catalog mechanism. And last, there's oftentimes a data processing piece. That's the compute layer, the part that actually takes my SQL query, breaks it down into an abstract syntax tree, turns it into an execution plan, then executes that execution plan to actually give me back the results that I need. Again, how does that all work? I don't necessarily need to understand those implementation details. It just works. And that's why we love these systems, because they just give us a nice bundle of all this functionality for us to be able to just work with our data, whether we're talking about transactional workloads in a database that tend to be row-based, or we're talking about analytical workloads in a data warehouse that tends to be more columnar-based, whatnot. But then again, this is the first time you start seeing sort of like this idea of a catalog. Okay, whether it's a database or a data warehouse, the catalog is acting as just really a mechanism within the bundle that is the database or data warehouse that's just tracking the tables, that knows, hey, there's an orders table, a users table, a cards table, a products table, and so forth. Okay, but again, you never really think about the catalog. It's just something that's part of the system. You're not thinking of it as a singular piece. And that's why oftentimes when people think of the word catalog, really what they oftentimes think about is what's referred to as enterprise data catalogs. Okay, and these are different. These are things like Elation or Calibra, and these are more data discovery tools for humans. So the way I always think about it is when I think of catalogs for databases, data warehouses, and data lakehouses, I'm thinking of a tech catalog. It allows my technology to discover the tables, while a enterprise data catalog is a human discoverability tool that allows my users, my team, my consumers to discover, be able to kind of look through a catalog of different data tables that I have across many different places and identify which ones exist, be able to request access for which they exist, find documentation and data on those tables for their ability to understand the available data. And again, these are like Elation and Calibra. So I don't use Elation and Calibra for like Dremio or Spark to know which tables I have. I use it for my business users to understand which data sets I have. So when I talk about Lakehouse catalogs, I'm talking about something a little bit different. But to understand what a Lakehouse catalog is, we need to answer the question, what is a data lake house? Okay. And as we remember, like the database and the data warehouse, these were very coupled systems. Okay. In the sense that all those pieces were all just kind of in a box. And all that was abstracted away from me. And that's wonderful. The problem is that means every box has its kind of own way of doing things. And that means if I want to use, tool A and tool B, I have to make sure that the data is located in tool A and tool B, which means I end up having to replicate my data. And that means all the costs that comes with data replication in the firms of compute costs for the ETL work, and then all the troubleshooting that comes with more and more ETL pipelines and so forth. So wouldn't it be nice if I could have all my data sort of in a place that's just sort of openly accessible? And this is kind of has become what the role of the data lake has been. The data lake, just basically the idea being that you take some sort of distributed storage layer, like an HDFS or object storage, and you store your data as files in that storage. Okay. And then you can then access that storage with tools that know how to access those data files in terms of things like Dremio or AWS Athena. They can then run query on your JSON files, your CSV files, your Parquet files, and whatnot. The problem is that sometimes your data files your data gets really big. Okay, so oftentimes your data sets get bigger and bigger and bigger, and your queries get more and more complex. So things like CSV and JSON become not quite fit to do the job. So you start moving towards Parquet. But then you get to a point where your data sets get so big that your data sets are stretching across multiple Parquet files, sometimes hundreds of thousands of Parquet files. And the problem is that each Parquet file isn't aware of each other. They don't have this. There's a lot of metadata that breaks things down in the Parquet file, but there's nothing that kind of binds them together. That's usually would be the role of the table format. And there's nothing sort of tracking, hey, which data sets exist, aka catalog. So these pieces are missing to really have the same experience as you would in a data warehouse. So the idea was, how about we add those pieces in? And that's where you get the data lakehouse. We take the storage layer. You already had your distributed storage layer, HDFS, object storage. You take your existing compute layer, whether you're using Dremio, AWS Athena, or others. And then what we do is we say, hey, let's take these Parquet files and wrap them into tables using a table format like Apache Iceberg. Then let's track those tables and govern those tables using a catalog, like many of the catalogs we'll talk about throughout this course. Okay, and that's where we get into sort of a Lakehouse catalog. The job of a Lakehouse catalog is to track the tables. And generally the way it does this is by tracking the location of the table. Now there are generally three main table formats: Apache Iceberg, Apache Hudi, and Delta Lake. Now Delta Lake and Hudi, basically when you want to identify a table, you're identifying essentially a directory location. You're saying, hey, this folder is where this table is. And then the files in that folder have a very particular physical structure. So like they're all laid out in a very particular way that allows an engine to read those tables. While Iceberg works a little bit differently. It can have, it's not physically married to any physical place where the files have to be. So in that case, what it does, it has an entry point called the metadata.json, and then that would be which you located. So when you take a look at these Lakehouse catalogs, they're either going to tell you, hey, this is the folder that Hudi or Delta Lake table is in, or this is the metadata.json file that tells you about that Iceberg table. And that's the idea. So they're saying, hey, we have, a sales table, and the location of that metadata.json or the location of that directory is here. And it allows basically me to connect this catalog to Dremio, to Spark, to Snowflake, to DuckDB. And now that catalog of tables becomes immediately available. I don't have to go register each individual table or constantly redesignate, hey, where that table is. The catalog does that for me. It becomes sort of the arbiter of truth of which tables are available and where they are located. That's the role of a Lakehouse catalog. Okay. Whether all that data is stored in one central repository, like just on S3, or if it's stretched across multiple repositories, maybe some tables are on Azure, some tables are on S3, as you can kind of see in this example, where we have a table that's on S3 and a table that's on Azure, and so forth, and tracking any other assets we may have in our Lakehouse. But I'm going to specifically focus on Apache Iceberg just because it has there's a couple of extra layers to the catalog story when it comes to Apache Iceberg that are important to understand. So if you've been around for my Apache Iceberg crash course, which if you haven't seen the Apache Iceberg crash course, you can register for that at dremio.com and watch those on-demand recordings. But Apache Iceberg is a format that really works well and really has a catalog as part of its design. Because again, as I mentioned, the way you know what the Apache Iceberg table is through that file called metadata.json, and it's the catalog that tells you which is the right metadata.json. Okay, and we'll come back to that mechanism in a second. But Apache Iceberg basically breaks down its metadata into 3 layers. There's the metadata.json, okay, that basically tells you, hey, this is the schema of the table, this is how the table is partitioned, here are the snapshots of the table, all the high-level details, that is the structure of the table. So basically what would happen is that a query engine like Dremio would say, hey, let me go access the catalog that you've connected to Dremio. And then it would say, okay, hey, this is the metadata file for that particular Iceberg table. I would read that, understand the structure of the table, and then that metadata file would then point me to a manifest list. Every snapshot gets a manifest list that describes the groups of files that are part of the table. Okay, so saying, hey, these chunks, which are referred to as manifests, are part of the table at this point in time. And using the data, and generally it has aggregated statistics on those chunks, and which generally means ranges of partition values. And I can take those ranges of partition values to determine, hey, does this chunk even have data relevant to my query? So I can throw out big chunks of files right there and begin reducing the surface area of my query. And then once it gets rid of as many chunks as possible based on the partition values, it can then go to these individual chunks, the manifests, take a look at the individual files, and use the stats on those files to then eliminate files from the scan plan. So then at the end, the Iceberg metadata allows you to generate the narrowest list of files that you would need to scan in order to accomplish your query. So the table format, again, not only enables you to know what files are part of the table, but gives you the metadata to smartly scan them to make sure you don't have to scan all 100,000 files. Maybe you only really need to scan 20 for your particular query, and then points you to where those files are in storage. But in that case, as you can see, the catalog mechanism is quite important to how Iceberg works. Like you can do some stuff with Iceberg without it, but really, if you want to make sure you have a nice, consistently defined set of tables that any user will access them and always access the consistent definition of the table, you want a catalog. So let's talk about that. So again, specifically what a catalog does in the world of Iceberg, okay, is that it acts as the arbiter of where is the table, specifically where is the metadata.json for that table, the current one. And so any tool, so again, Dremio, Snowflake, Spark, Flink, in this example, would contact one of many different catalogs that exist, okay, whichever one that you choose to use, and say, hey, I'm looking for table A. And I'd say, okay, and then the catalog would say the current metadata.json for table A is located here on your storage. And that would allow the engine to then run and create the scan plan. And that's essentially how these work. So again, bottom line is a catalog is just telling you, hey, what is the right metadata.json? Because every time a Iceberg table changes, a new metadata.json is created. Okay, I create the table, a new metadata.json. So for example, like this is maybe the table creation. Maybe I inserted some data. So that's like the V2. Then maybe I inserted some more data. That's V3. Every time I modify the table, a new metadata.json gets created. So the catalog becomes the arbiter of which is the right one. Okay, because even though this looks pretty straightforward, it's like, why wouldn't I just know to go to the highest number? Not all metadata.jsons have, sequential numbers as the prefix to the file name. It could be like a hash of some sort or something that might not be as intuitive. So you want the catalog to be sort of the source of truth. Now, there are 2 categories that catalogs fall into in Iceberg. One, there's a file system catalog. In the file system catalog, the idea is that you do just say, hey, this folder is the table, in the same way that you could with like a Hoodie or a Delta Lake. And in this approach, the way it works is that the location of the correct metadata.json isn't stored in this external system. It's stored on a file called versionhint.txt. And that file says, hey, guess what? v3.metadata.json, that is the file you want to access. That's the right metadata.json. Now, the problem is this file does have to be updated. Typically in Iceberg and typically in all these formats, you try to not edit files. You try not to update files. You try to always write new files. This way you run into less issues with concurrency and a couple other benefits. Also makes it easier to reproduce historical states, things like that. But with version hint.txt, since that's the file that it's going to refer to figure out what's the right metadata.json, the file location in this file has to be updated. Now, not all file systems have the same guarantees. Okay, so you might, in certain file systems, you can end up with an issue where if multiple updates are trying to happen to the same file at the same time, you could end up with inconsistencies. Okay, and then that's generally why this approach, while great for experimentation or just one-off reading or stuff like that, isn't recommended for like a full production system where you expect to have a lot of concurrent writes. Okay, because again, you might have issues updating this file. So typically what you use is a service catalog. This is where you actually have a separate running service that has a catalog, and then that catalog will track your tables and the locations of your metadata.json. Now, the beauty of service catalogs is that they can do a lot more. Okay, they're not just tracking the location of the right metadata.json. As you can see, they can expand into several different areas. They can expand into governing your tables. They can expand into basically federating other catalogs, all sorts of different cool things. And the problem originally, and this is where we get to the story of the Apache Iceberg REST catalog, because even whether you're using Apache Iceberg or not, very likely the REST catalog spec will just become the standard for all catalogs, for all formats. And I'll talk a little bit as to why and how that can happen. But basically, the story is that you had a lot of problems with catalogs when Apache Iceberg first started, because the way it was designed initially was you had one API. You had a Java API for Iceberg, and the catalog, most of the details of how the catalog worked were between the server and the client. So basically, there wasn't a distinction of, hey, this is what the client library defines, and this is what the server defines. So there was a lot of logic in the client. So then basically you created like a separate Java class for each catalog. Now that's fine when you only have to create one class because you're only working in one language. The problem happens is as you start expanding, as Iceberg starts growing, you now have Iceberg APIs in Python, Rust, Go. So now in that case, you now have to, the Java library that you created in Java doesn't work for those languages. So you then have to recreate that catalog library for each of these other languages. So this means a tool that's using Iceberg in Python will only be able to work with catalog Y if that library has been re-implemented there. So this starts fragmenting things, right? Basically, I have catalogs that work in Java, but they don't work in Python. And you start starting to see fragmentation language-wise. Because you have to re-implement them per language. Awesome. And then also, when you have like managed services, so basically if you're using like Spark or Flink, some sort of open source tool, you can just drop those libraries in. Okay, so to extend to whatever catalog. But if you're using a managed service, then what happens is that what catalogs are supported are built into the tool. So every time there's a new catalog, they'd have to like then build out and build the tests and do all this functionality to add support for each individual catalog. And that becomes very cumbersome. And you start having this really fragmented support for catalogs. And then on top of that, if the logic is in the client, especially if you're again using, if you're using an open source tool like Spark or Flink, hey, are you loading up the right version of the client library? Are you loading up an older version that has bugs? There's all these different things that are out of the control of the catalog server that are now you have to hope that the end user does right. And if not, causes problems. So there's all these sort of like different issues that weren't perfect in the original way of how do you add a catalog to the Iceberg world. So again, so you'd have this problem. Again, you would need a custom client for like every language, and then different managed services would have to then re-implement support for those expanding catalogs. If you're using an open source tool, then you have to make sure that you're using the right version of that catalog's client library. Lots of different things that just made it very cumbersome. So the response was to create a REST API to say, hey, you know what? Let's make the client as much of a dummy client or like a very thin veil and move most of the logic over to the server. So how each different catalog works, we're going to let the server-side code handle that. Okay. Instead, what we're going to do is we're going to say, how do you talk to that server, and say, create a standard for how you talk to the server. So that way, the way the client works, no matter which catalog you're using, works the same. Okay, so they did this through a REST API standard called the Iceberg REST client. Okay, basically, again, it's a very specific thing. It's not like, hey, a standard for how everything a catalog ever does. It specifically deals with how do you deal with a catalog for reading Iceberg tables and writing to Iceberg tables and working with Iceberg tables. Okay, anything outside of that sort of realm generally isn't handled by this particular specification currently. Okay, so catalogs will still have maybe additional REST APIs for other features that they may have, such as like catalog management and whatnot. But the beauty of this now is that now it doesn't matter what, you can have as many catalog services in the world and different versions of catalogs, but you can use the same client. So now different services, like different managed tools, don't have to re-implement the same functionality over and over again with different catalogs. They can just use one library that allows you to connect to all catalogs. This is especially useful if you're a company, it's like some large companies, they actually build their own completely custom in-house catalog. And this gives them a way to be able to use these managed tools, basically because they're all using the same interface. So by creating a standard interface for talking to the catalog, you got rid of a lot of these issues. You don't have to worry about, hey, is a client up to date? There's only one client that has to be implemented for each language, and then every catalog can use that client, making life way easier. And that's become the standard. Okay, and there's many different tools that support this standard. Okay, as you can see here, many of the tools that do have currently have REST catalog support of some level. Okay, there's many catalogs that support the REST catalog. So, and these are many of the catalogs that we'll talk about throughout this course, such as Nessie, such as Gravitino, such as Unity, and Polaris catalog. Okay, we'll talk about all of these more in depth as the course. So we'll talk about Nessie and Polaris in the next session of this course. Later in November, and then we'll talk about Gravitino and Unity in the final session of this course later in the year. Okay, but the beauty of this is that now you end up in a world where you can use any catalog can talk to any tool. This creates a sort of, because you have a standard way of how does a server implement its endpoints and what client can speak to that. And that makes life a lot easier for everybody. And this means having a Lakehouse and being able to have lots of options for, hey, which catalog do you want to use for your Lakehouse? Much easier, because all your tools can work with all catalogs, as long as they implement and support this REST catalog specification. And that's been growing quite a bit. And more tools are starting to really kind of adopt that REST catalog specification. Now, I mentioned earlier that this can also open up the door to just being sort of the standard way you talk to the Lakehouse. Because even right now, there's discussions over the next iteration of the specification, so the V2 spec for the REST catalog. And one of the things that's been part of that discussion is something that's called the scan plan endpoint. So the idea is that right now, the way the catalog works is the catalog is just kind of returning you the details for like, okay, here's the metadata.json. And the engine is doing the scan planning. So Dremio would get back the location of the metadata.json. It would read that metadata.json, and then it would then go access those individual files of metadata and then create the list of files that need to be read. What is possible if you implement this with a scan planning endpoint is that you could choose to opt out of the tool doing it, the engine doing it, and allow the catalog to do the scan planning. So in that case, the catalog, different catalogs use this for different reasons. They might just use this for like caching to optimize it. But what could theoretically be possible is that if only the catalog does the scan planning, then they could do a scan plan for a hoodie table or a Delta Lake table if that catalog wants to build that that functionality, and the engine doesn't need to worry about it because the engine is just going to receive the list of Parquet files that it needs to scan, and so it doesn't really care about table format anymore. So theoretically, in the future, you could end up in a world where basically the Iceberg REST spec can become sort of like the universal catalog spec for all tables of all formats. Again, time will tell, but I think that would be really cool. So that's the deal there. And that kind of brings us to the end of our introductory section. But again, just to kind of recap the things that we learned, is that one, the term catalog, again, just generally means to be a listing of items. Okay, when you think of like a JCPenney catalog, that would give us a list of products that we could buy for JCPenney. A catalog for a database or a data warehouse it gave us a listing of tables that we could access in that database or data warehouse, versus a enterprise data catalog, which gave us a listing of assets that we had across our data in the enterprise across different sources. But a Lakehouse catalog allows you to have a listing of which tables are accessible in your Lakehouse, meaning across your, basically these data warehouse like tables that you have stored directly in your data lake storage, which could be in formats like Iceberg, Delta, Hoodie, Pymon, etc. But there's a lot more of these. And again, this is a new space. And one of the most interesting things about this space is that catalogs are expanding beyond just listing items, but they're expanding into being the source of governance. Because at the end of the day, whatever tool you're using, what is the thing that's going to connect? The catalog. So then this logically becomes a place to govern your tables. Okay, so sit there and say, hey, what are the access controls for my tables? So that way you get consistent access controls across all your different tools. Okay, so, but what other things may you want to have accessible across different tools? Maybe things like lineage, maybe things like UDFs and whatnot. So the idea is that the conversation of sort of what the role of the catalog and what should exist within the engine and what should exist within the catalog, now that you live in a world where your tables need to be accessible by multiple tools, is changing. And this is why the catalogs have become sort of the center of the conversation when it comes to Lakehouse, because that's going to be where all the functionality across multiple tables, across multiple tools, is probably going to end up getting housed more and more so as these different catalog platforms continue to evolve. And again, we're going to examine each of these different catalog platforms over the next couple of sessions. So hopefully you guys, I'll see you guys in the next couple of sessions of this course. So this wraps up the first session of this course. Now what I'm going to do is I'm going to open it up to questions. So if you have any questions, feel free to put them in the question and answer box, and I will answer those questions. And I will give everyone a minute to ask any questions that they may have about today's session. I'll give it a minute. Okay. Again, write your questions inside the question and answer box. So instead of raising your hands, do put your questions inside the question and answer box, and I will answer them. One more minute to type out their questions. That's in the question and answer box. Should be at the located screen. I know I see one hand up. Just type your question in the Q&A box. Once. Oh, here we go. Would you mind sharing your opinion regarding a lakehouse that is multi-table format? I mean, there's different reasons why you would want to have a multi-table format lakehouse. I don't think the question is whether it's bad or good to be multi-format. Sort of the question is should always just be sort of, what is your end goal? So imagine a situation like this. You are doing a lot of different AI/ML workloads, and you've been using Databricks because you like the base of that sort of managed Spark experience and Photon and all this stuff. But you now also want to basically serve BI dashboards and take advantage of some of like the features that Dremio has, like reflections that really can help make BI dashboards really nice and fast and performant on your data anywhere. So in that situation, you would probably take advantage of Unity Catalog. And Unity Catalog has this feature called Uniform that allows you to broadcast your Delta tables, which you would be using in the Databricks platform, but be able to maintain sort of a separate Iceberg copy of that metadata. So in that situation, you don't have two copies of your tables. You just have multiple copies of the metadata, which is a much lower storage imprint. And in that situation, you're doing that so that way, one, Dremio can then leverage Iceberg, the Iceberg version of the metadata to bring you those really fast dashboards on top of those tables that you have in your Databricks setup, and so forth. Or some people really like they really have like very low latency requirements when it comes to streaming. So they might decide they really want to use Hoodie. So they use Apache Hoodie and they land that data and they land it really fast, but they really rather all their tools use Iceberg. Then you can use a tool like Apache Xtable to say, okay, hey, let me land all my data as Hoodie just to get that that hyper low latency on the streaming side, but then read it as Iceberg. Now, the one thing to keep in mind when you start working with multiple formats is that there is things you lose when you write to one format versus another. And I'm not saying that there's one format that's the ideal to write, and it depends what you're doing. But for example, being able to read an Iceberg is great, but one of the nice things about Iceberg are things like partition evolution, hidden partitioning, and those are right side features. So if you're not writing to that format, you can't take advantage of those right side features because it deals with how it writes the data to those Parquet files, which is more part of the way like Iceberg's logic when doing so. But again, that might not necessarily be your priority, depending on sort of what is the problem you're trying to solve. So there are different ways that you might have a multi-format lakehouse, whether you might be using different formats for different parts of your workflows. Okay, and so the next question I have here is, what is the future of Iceberg? I know that Tabular was acquired by Databricks, and Databricks announced a new uniform format will be on the scene at the end of the year. I mean, Uniform has been on the scene. Like they announced Uniform back in, I think, 2023. And Uniform is a cool feature. Essentially what it does is it's writing Iceberg metadata. Now, again, I imagine with the acquisition of Tabular, as that acquisition plays out, you might start seeing more Iceberg functionality within the Unity catalog. What those plans are and what that will look like hasn't been, really shared. So I don't know what the future of that aspect of like what Unity catalogs with future functionality with Iceberg beyond Uniform will look like. What has been sort of discussed and hinted at is a desire to kind of help the building blocks for all formats kind of start converging. And where you're starting to see this a lot is in discussions over the Parquet file format. Okay, where you're starting to see collaboration across all the different formats on evolving the types of the data types within the Parquet format, particularly like things like variant and geotypes and things like this. Because the idea is that once Parquet can support X data type, then the table formats can support that data type. And if everyone kind of agrees on what those data types are, it becomes much easier to then migrate and create conversions much more efficiently between formats for situations where you need that. So I do see that there's a lot more collaboration there than there was in the past, and trying to make sure that the primitives of these, particularly in the Parquet file format, are more thought through as a community between the different communities. So that's what I see. But overall, like you take a look at the momentum, I mean, you have two really big announcements this year. Like, okay, one, the fact that Tabular was purchased by Databricks is in itself a large statement as to the importance of Iceberg going forward. And then two, especially particularly with like Snowflake, when they initially announced like the Polaris catalog and how the Polaris catalog has kind of become this big community project, with companies like Dremio, like AWS, like Microsoft, whatnot, all kind of at the table to help evolve that project. It's another sort of statement to sort of like, you have the center of gravity that lake houses are, because everyone wants that sort of more portable data that, they want to reduce their storage costs. They want to be able to deliver that data faster to the endpoint, have that less data movement, and have overall that sort of better experience on the lake. And basically, while table formats give you the guarantees, it's going to be the catalogs that give you the experience that makes the lake feel like a data warehouse. And basically, that's why you're seeing everyone kind of move in that direction. I do think, again, as I mentioned with the scan plan, probably there'll be some level of convergence over time. But again, there is the big distinction between formats when you write is each of them kind of manages how they optimize the data. So what happens is that each one writes data in a way that it's optimized for how it reads data. So when you write in one format and then read in another, you might lose out on some of those optimizations, which is why like those are things you want to think through sort of what your goals are and work backwards to figure out sort of what this should look like. Yeah. So that would be my thoughts there. But overall, I've always been bullish on Iceberg. I still am. But honestly, I am bullish on lake houses in general. And I think the lake house space will continue to grow. And there's a lot of other aspects of the lake house. And really what's captured my imagination lately is sort of what will be the role of the catalog. Like what, again, imagining like things like catalog as like the home of lineage, as the home of governance, as the home of pretty much all these kind of pieces of data that you would want across the entire sort of end-to-end life of the data set. Okay, we got another question in here. Let's see here. Hi, Alex. Can you talk about the pros and cons of having the governance within the catalog layer and how the capabilities may differ by the catalogs available in the market today? I can't think of any particular cons. What used to happen before, which is still kind of what happens today, is that the catalogs didn't have governance, and what would happen is that the governance would have to be done at the engine level. So you'd have different sets of rules for every tool that accessed your data, which isn't ideal. So being able to say have a clear set of rules, that hey, if the same user accesses the data with 5 different tools, they're going to be consistently only accessing the data they should. That's a good thing. So I don't really see any cons there. Now, just in general, with the decoupled nature of the Lakehouse, there are logistical challenges that are more like just kind of wrapping your head around the space. Because again, right now, most of the catalogs, especially a lot of the managed services, are cloud only. Okay. And basically with the REST catalog, you have this thing called the vended credentials. Okay, but then what happens when you start moving into like Dremio with its recent catalog announcements, you're starting to move into this hybrid catalog world. Okay, where you're going to have some tables in your catalog that might exist in on-prem locations, and then some tables that exist in cloud locations, and how do you manage those credentials and manage not only just like who can have access to the table, but make sure that the tools are able to kind of consistently access the table. And that's where things get a little confusing, because one tool may not be able to access the particular storage layer that a particular table's at. So even though the user may have access to the table, the engine they're using may not be able to access the table because they don't have access, or they don't have the capacity to access a particular storage layer. And I just think that's going to be more the burden of us who build data lakehouse platforms to try to make a better wrapper around that, so that way end users have to think about that less. And I mean, that's definitely one of the big considerations and thought processes here at Dremio. And how do you create like a better wrapper so that way you have that better hybrid experience. But the idea is like, what happens when suddenly all your data really can truly be in one portable catalog, all the different sort of logistical edge cases that can happen, and how do you smooth that so that way it's as pleasant an experience as possible. Cool. Okay, so we answered that. Next question: what state is the access management in Iceberg REST catalog API? Is there any catalog that's fully implemented access management? In the REST API, there is no access management. Okay, so anything that's outside the bounds of the REST API currently. I think there are discussions about building some primitives for that, but generally all access controls are external to the REST API spec, which makes sense. At the end of the day, the REST API spec is only dealing with making a request for a table or submitting a new snapshot for a table. You don't necessarily need access controls to be built into it, because basically what would happen is that when you first connect to the catalog, you would pass in credentials, and then the catalog would be aware of, hey, what access that credentials has. So in that case, like the REST API endpoints don't need to be really aware of that. It's the server that needs to be aware of that. And then generally right now, each catalog kind of has its own separate sort of way of handling access controls that would be done through separate sets of REST API endpoints. But generally, again, you're not doing access control via some sort of like universal SQL currently. Usually that would be something you handle separately, and then that gets enforced as people bring it to the different tools. So I don't expect that becomes the realm of the REST API catalog. There might be some bits and bobs. I know like I've seen discussions about it that go back and forth. But again, the idea is that the REST catalog is more concerned with how do you facilitate the ability to be able to just take those tables to operate on them from tool to tool. Things like managing your catalog is something you don't necessarily always want to do to the tool. You don't want someone managing your catalog from any engine. You're gonna have like probably a separate admin team or a separate team that kind of handles the provisioning of access controls, and they're not dealing with all the different engines that the end users of those tables are connecting to. Now, if we're pulling aspects like access management, scan planning to open catalog layers and implementation, what do we think of the future specializations for compute engines? I mean, over time, compute engines become basically, it's all become more about raw performance and basically, basically it becomes a sort of like the separate piece, and like that, with that sort of like, business models will change and whatnot. Now again, what does that look like when we get there? It's still probably years away. But I mean, you're starting to see kind of realms of that. Like, you take a look at a lot of the work with projects like data fusion, substrate, um, a lot of this work about, what Voltron does with like the idea of composable data systems. You're starting to see the pieces starting to be there, so that way basically even like the actual query engine is breaking up into pieces. And this is actually where like the query planning becomes a separate thing, and that's where like substrate comes in, where you actually can create a separate representation of the query plan, and then any tool that supports substrate, you can just bring your query plan or your substrate execution plan to it, and it can just execute the plan. And and there's even discussions about that in like the view feature of Iceberg. They sit there and say, right now views are represented by SQL, but again, SQL dialects are not the same across all engines. So what if that was represented by substrate? You use sort of this universal primitive to represent sort of, hey, this view is really the result of this sort of execution piece, and that's something that all engines could theoretically support and understand without having to understand each other's SQL dialect. So there's a lot of really interesting conversations. Again, chances are like, how does that then implement, and how does the business models will change over time as all these different pieces become very, very composable and very, very commodified. And again, I would assume that the catalog will become the center of many business models in the future, just because it will be where the functionality is housed. And what does the pricing for that look like? I don't know. Again, I feel like I think Tabular kind of hinted at, like, its business model at the time that it existed kind of hints at what that will look like, because that's essentially what they did. I mean, they were a catalog only platform, that essentially brought as much as they could into the catalog, and let you bring the compute. So that's an example of what that model can and probably will start to look like as companies start to move more and more into making catalogs not just something a part of their platform, but their central offering. There are also design philosophies where you put your access management layer on your enterprise data catalog, and then push policies into respective catalogs used for consumption. Any thoughts on doing it in a technical Lakehouse catalog? At the end of the day, like, anything's possible. Like, the beauty of the way catalogs work now is that you can, especially with the REST spec, is that you can have catalogs trying different governance, different types of access control, the designs, and be able to switch pretty easily among them. And even Polaris, there's conversations of having a plug-in playable governance layer. So that way, like, the current existing principles and entities and whatnot, design of the Polaris governance system is maybe the default system, but it is something that you can actually, that the way the actual catalog works out, you can swap out. And you can plug in your own governance system on top of it. So that way different platforms can still use the primitives that Polaris provides, but then use maybe their preferred sort of access scheme for their platform, yet still, be compatible with the REST catalog, still have all the catalog functionality, the federation of catalogs, all the other really good stuff that Polaris brings, which again, we'll talk more about in the next episode. And with that, that is the final question. Hopefully you guys all enjoyed all that fun catalog discussion. You'll get an opportunity to ask more questions and hear more about catalogs in the next episode. Thank you all very much. Have a great day and enjoy.